Everybody can earn answer sheet. If you didn't get one, you can come here to have one. So we will discuss the answer of the midterm exam. So the first question. The three-phase rectifier is shown in figure 1. So this is figure 1. The current I out is a constant. So the current I out is a constant. It is proposed to turn each switch when the corresponding voltage is positive. So if VA positive, then HA on. VB positive, then HB on. VC positive, then HC on. So if the voltage is positive, then the switch is turned on. A, will the operating method meet the requirements of KVL and the KCL? Please explain the reason. So if we set this rule, then we have the switching function. HA here, half on, half off. This is HA. We have HB here left 120 degrees. So HB should be turned on here. And turn off here, and turn on again, so that. So this is HA, HB, and HC. HC should delay HB 120 degrees or advance HA 120 degrees. So then we can join here. We have to lay 120 degrees. So you turn on here. Here. And we can add this one. So HA, HB, lay 120 degrees, and HC, like HB, 120 degrees. So in this case, we can check FA plus HB plus HC. So here this is 1, 1. So the total should be 2. Here is 0, 1, 0. Total is 1. Okay. Here is 0, 1, 1. The total is 2. Is it possible HA plus HB plus HC larger than 1? No. So then this disobey the output current should be constant. So only one switch turn on. If 2 switches turn on, then short circuit, right? So do we have any question about problem 1A? Any problem about 1A? Any question? So in this case, we have proposed a new method. What is our new method? We said if the voltage is the peak, the maximum, then we can turn off. So then we have HA here, then 2 steps. HA here, so this is HA. And then we have HB here, and HB here. Then we have HC here, and HC here. Then we can get output. Just with our assignment. So this is output. So we have to modify to set a new law. Only the voltage is the highest, then they can turn on. The other two should be turned off. In this case, we can see HA plus HB plus HC is equal to 1. So do we have any question about problem B? This is our assignment. We discussed this before, okay? So this is problem 1, A and B. So assume VA, VB, VC, and please compute the output value of the V out. So we can compute V out. So what is V out? So we have V out. So V out, we can find one period, maybe from here to here, one period. So in this case, the whole period is T, is 3 period. T. So then we can set it is T divided by 3. And we have to integral 1/3. But it is symmetrical. So we only integral from T divided by 12, which means 30 degrees to 130 degrees. And then V all sine omega t, d omega t. So here, this is 30 degrees, this is 150 degrees. So we integral from 30 to 150, and this is the same. So we only compute one time. So this one, we can get 3t V O minus cosine omega t from 30 degrees to 150 degrees, and the result is 3 square root of 3 2 pi multiplied by V O. So I think we have assignment before. So this is average voltage. So do we have any question about problem 1? Do you think it is very difficult? or it is okay? If you think it is okay, please raise your hand. If you think it is too hard, please raise your hand. I think we have assignment before, right? Very similar. If you understand, then you can solve problem 1 easily. So it should be no problem. Okay? So this is problem 1. Okay? Okay? So you can erase the problem 1. Erase here, and then we go to problem 2. So let's check problem 2. So problem 2, it is proposed to convert single phase. So this is single phase input. And this is 60 Hertz. So single phase 60 Hertz AC voltage to single phase output should be 30 Hertz. So this is single phase, but the frequency is only half, 30 Hertz. Current by using a method called integer cycle control. So we call this is integer cycle control. The circuit is shown in figure 2A. So here, this is the circuit. The method works as follows. Switch 1 will be on 1 full period. So switch 1. So this is switch 1, turn on. So we can draw the switching function because switch 1 turn on here. This is SW1. Switch 1 turn on. So if switch 1 turn on, V in equal to V out. So V out, this is V out equal to V in. So you can see if switch turn on, then V out equal to V in. So switch 1 turn on for full period, one full period. And then it turn off. So switch 1 turn off here. Here turn off. If switch 1 turn off, then this is turn off. Then switch 2 turn on. Then output becomes 0. We have switch 2 turn on here, then output become 0. If switch 2 turn on, then this is 0, so output is equal to 0. If switch 1 turn on, then output is V in. If switch turn on, switch 2 turn on, then output is equal to 0, and so on. Then switch turn on again here. Then switch 2 turn on here. Switch 2. Let's go check. Switch 1, switch 2. Yeah, this is correct. Then switch 2. Switch 2 turn on here. So it is like this. If switch 1 turn on, V out equal to V in. If switch 2 turn on, V out is equal to 0. So plug the switching function. So first, this is switch 1 switching function. This is switch 2 switching function. Both of them 50-50 duty cycle. Okay. So this is problem A. So you can draw this waveform. It is okay. B plus the switching function of S2. Okay. write the Fourier series of H1. So now we want to write the Fourier series of H1. So you can see this is V out here. And the V out equal to H1 V in plus H2 0. So we have V in here, so H1 V in plus H2 0. It is V out. So this is V out, right? So we learned that before, so you just apply the fundamental idea. Then you can draw H1, H2, and also V out. Then now we want to calculate the H1. Like this. We learned that before. And then it is half-half. So A is equal to 2. So this is N, omega is 2 pi F. T is T. So we can put it here. So it is so this is sine N by A is 2 divided by N. F is 30. So you can write down H1 is equal to this equation. So we learned that before, right? So do you have any question about problem 2? Do you think it is difficult? If you think it is difficult, please raise your hand. Do you think it is okay? If you think it is okay, please raise your hand. I think it is okay. Just apply fundamental idea, right? Not too hard. Okay, so we finish problem 2. Now we go to problem 3. So problem 3, first, we already know this is 6 angle, this is 6 angle, and this is 2/3 T, and this is 6/3 T, 6/3 T, so this is 1 T. So we can easily calculate VL. VL is equal to this voltage multiplied by this time interval. So we have this one. And also these two interval, this is 0. And then we divide it by T and then take square root. So this is RMS definition. If you have a root mean square, it is equal to this height multiple square multiplied by this time interval plus this height multiplied by this interval. Then we can easily calculate. So it is 489.94. So this is line to line voltage. And then we can go to V phase voltage. Phase voltage we have 1, 2, 3. So for the first one, this is 2/3. This is 1/3. So we can have first one 1/3 V squared multiplied by this time interval plus this one multiplied by this time interval plus this one multiplied by this time interval. And then we can divide it by whole interval and take square root. And we can find it is the result. So we can calculate. So it is this one, 2/2 on 4. So this is phase voltage. This is line to line root mean square voltage. And then we can move to the fourth question. So what is the application of CSI? The answer is high power. So what is SVPWM? So we have 6 regions. And each region we have to use the simple math to calculate the VO star is equal to V1 star T1 plus V2 star T2 plus V0 star T0 divided by T. Then we can use this method to do the space vector PWM modulation. So what is the switching function? If you turn on, it is equal to 1. If you turn off, it is equal to 0. So how about the matrix converter output? If you set output is voltage sink, then you have to use a capacitor. But because output voltage is changing, so we have increase or decrease. And the C is very huge, and the IC is too huge, almost infinity. Then you will burn your capacitor. So the output should be current sink, not voltage sink. So do we have any question about problem 3 and problem 4? So do you think that this is very hard, very difficult? Or do you think this is okay? If you think this is very difficult, please raise your hand. Okay. So I think you don't need to write a lot. Some students only write down 1 page, but I get 95. What I need is correct answer, not copy a lot. Okay. So very simple. If you understand, just a brief explain. Okay. So any question or any problem about the midterm exam? So you can take 1 sheet. So anyone need the answer sheet? Okay. You can have a look. If you have any question or any problem. So anyone need one? Okay, any question? Okay, if no question, then I will return your answer sheet. If you find some mistake, I will regrade. It could be higher or lower than before. Okay. So any sound. Okay. And S key. S key. Okay. Nothing. Okay. And numeral. And Toshibi Ehan. And Wu Kai, Wu Xiangkai. Chen Qinghan. Chen Qinghan. Anybody can take for him. Chen Qinghan. Unique. Anybody can hear him? Edinta. 郑佑成。宋玉生。蔡国浩。刘俊志。黄子豪。赖明轩。Morgan Fayette. Feja Punia. Reiko Zakri. Mosebi Umi. Mosebi. Anybody can hear? Mosebi.郑子轩。邱品池。Hennifer。季坤颖。So you can check your answer. If you think you need correct, you can come here. I will retweet. But it could be higher or lower than before. So this key. So you can check your answer. So if you need correct, you should come here to put here. Otherwise, we don't change anymore. transfer. So, anyone need to correct your answer? Should you correct? So if no, then we won't change anymore. So just fix the middle term exam. But I guarantee everybody can pass. So you don't need to worry. You just come here to learn. So you don't worry about it. You could pass or you could fail. Everybody will pass the course. Okay. So now we can move to the lecture.
全部都出来搞笑的，一波全部恐龙，然后下一波全部喷走。
So in the previous course, we discussed about the AC to AC converter. last time we discussed about the AC to AC cycle converter. So cycle converter change cycle. What is cycle? Cycle means frequency. So if we need to change frequency from 3-phase to 3-phase, so 1, 2, 3 phase load, then we need this structure. So how many SCR do we need? So 1, 2, 3, 4, 5, 6. This is 12 for A phase, 12 for B phase, 12 for C phase. So totally how many SCR do we need? 36. 36. How about the waveform? Waveform is like this. So do you think the waveform is good or not good? If you check this one, it is like this. Do you think this is good or not good? It is not good. Why? Because harmonics is too huge. Do you think the cycle converter can increase output frequency? Input is 60 Hz. Can we create 120? The answer is no, because you use SCR. So you only can reduce the output frequency, but you cannot increase the output frequency. So there are several disadvantages for the cycle converter. So maybe 100 years people use cycle converter because it is AC to AC. But finally they found the harmonics is too huge and the output frequency is always lower than the input frequency. Then people give up. So nobody study cycle converter anymore. So if you go to a shop, you say I need a frequency changer, so I need a cycle converter. They say we don't have this kind of product because it is outdated. Nobody uses it. So what do people use? People use matrix converter. So what is matrix converter? We have 3 input, we have 3 output, we have 9 switch. So how about the 9 switch? Do they DC switch or AC switch? AC switch, because the input voltage could be positive, could be negative. The current could be positive, could be negative. So this should be AC switch. Can you use a transistor to replace AC switch? So if I need AC switch, can I use a transistor? If you use a transistor, the current is going this way. Do you think this is AC switch or DC switch? DC. You cannot go back. So you cannot use transistor. Can you use MOSFET? MOSFET, you always go this way, drain to source. But you cannot go back. So you have to use AC switch. So we will discuss what is AC switch. So then you can create your output voltage and you can create your input current. So what is the advantage of matrix converter? First, it is bidirectional power flow. So the power can go from input to output. It can go from output to input. And one stage. So we only have one stage. If you use AC to DC, then DC to AC, it is 2 stage. But this converter, only 1 stage. What is the advantage of 1 stage? High efficiency. Reduce power device. So simple, high efficiency. How about the input power factor? Input power factor is 1.0. It is good. It is good. So there are several advantages of the matrix converter. how can we determine the night switch? Which switch should turn on? Which switch should turn off? So we can say the output, we have to change to 30 Hertz. So amplitude become 110. So this is output. But output can come from input V in T1 plus V in T2 plus V in 3 T3. So the output, so we have V in 1. So we have V in 2. And we have V in 3. So this is output 1. So the output 1 is equal to this voltage, V in 1, multiplied by this switch, multiplied by T1, plus this voltage, so V in 2, multiplied by this switch, plus this voltage, multiplied by this switch. So we can see here. And how about VO2? It is, we have to shift. If we keep this T1, this T2, this T3, then we keep the same T1, T2, T3. Can we keep the same? If we keep the same, then the output 2 equal to output 1, right? But your output B phase is not equal to A phase, right? So what should you do? You have to rotate. So you say I have to shift. T1, I change to here. T2, I change to here. T3, I change to here. So you can see VO2 is V in 1, T3, plus V in 2, T1, plus V in 3, T2, right? We shift. So this is V out 2. How about V out 3? V out 3 cannot copy V out 2. They have to shift a phase angle. So I change T3 to here, T1 to here, T2 to here. So T2 V in, T3 V in 2, plus T1 V in 3. So we shift. Then we can obtain VO1, VO2, and VO3. Then we can calculate. This is output voltage, VO1, VO2, VO3. It is, we can design, VO1 is 110 volt cosine omega 0 t. How about this VO2? 110 and the cosine omega 0 t minus 120 degree. This is B phase. How about VO3? 110 cosine omega 0 2 t plus 120 degree. So we can determine output voltage. We have no V1, V2, V3. This is 220, 220, 220. This is A phase, B phase, C phase. So this is no, this is no. Then what do we need? We need to calculate what value of T1, what value of T2, what value of T3, right? If we know T1, T2, T3, then we put T1, T2, T3, then T1, T2, T3, then T1, T2, T3, then we finish. So how many are known? 3, right? T1, T2, T3. How many equations? 1 equation, 2 equation, 3 equation. 3 equation, 3 are known. How many solutions? So you have 3 equations. You have 3 equations. You have 3 equations. And you have 3 unknown. How many solutions? You have done algebra. You have 3 equations. You have 3 unknown. How many solutions? 1 solution, right? Everybody can solve this problem. So what is T1, T2, T3. T1, T2, T3. It is equal to the inverse. We move to inverse multiplied by VO1, VO2, VO3. So we can calculate this inverse. So we move here. So T1, T2, T3 is equal to this A matrix inverse multiplied by V out. Then we can solve the problem T1, T2, T3. Then you can graduate. So were you happy? Yes, because I found I can calculate T1, T2, T3. Then I put T1, T2, T3. Then I put T1, T2, T3. Then I can change frequency. I can change amplitude. Then I develop AC to AC. So I can graduate soon, right? Were you happy? Will you be happy? Yes, I'm happy. So you go back to calculate this math. How can you calculate this math? If you say this is A, the first problem you have to compute, determine A should be not equal to 0, right? If it is equal to 0, then you cannot obtain the inverse. This is basic rule, right? So you calculate the determine. Unfortunately, it is 0. So what is your inverse? No inverse. Then what is your dream? Broken, right? Originally, you hope tomorrow you can graduate because I can find A matrix. So I found A inverse. Then I say T1, T2, T3 is A inverse multiplied by VO. Then I can calculate T1, T2, T3 for unique solution. But now determine the equal to 0. This means we have 3 dimensions, but we only have 2 independent equations. The third equation is redundant, or it is dependent. Then we have no solution. We have no solution. So the student go back and they try to find T1, T2, T3, but finally he gives up. He say, according to the math, I have no solution. Then his advisor asked him to think again. You have T1, T2, T3. What is T1, T2, T3? T1 plus T2 plus T3. I said this is 1 sequence. I can say 1 millisecond. If you know T1, T2, T3 is 1 millisecond, how many parameters should you know? Do you need to know T1, T2, and T3? No. If I know T1 is 0.3, this is 0.2, how about T3? 0.5. So you only need to know 2. You don't need to know 3, right? Because the total is 1 millisecond. Now you have 2 equations. You have 2 unknown. How many solutions can you find? Unique solution. Then he graduated. So this is a good news because T sequence is a constant. So we only should know T2, T3. So then we have 2 equations. Then we can find T2 and T3. So finally, we have unique solution. So this is T2, this is T3. How about T1? T1 is T sequence minus T2 minus T3. So we solve this equation. So what is T1, T2, T3? They're related to T sequence. So each one, 1/3. They're related to output amplitude. They're related to input amplitude. They're related to output frequency. They're related to input frequency. And 2/3 pi and the T sequence. Can we use hardware to do the peta band? Can you use hardware to compute this? No. Too complicated, right? You have cosine. How can you use hardware to determine cosine? No way. So what can you use? Only DSP, right? Computer. So you have to use computer. Do you think that this is easy compared to SVPWM? Do you think that this is easy? This is hard, right? Because you have to know omega 0, you have to know omega S, you have to know T, you have to know T sequence, you have to compute the cosine, and then you have to compute the ratio of VO and VI, then you have to multiply by 2/3, then you compute this item. Then you have to know T sequence, 1 millisecond, 1/3, 0.33 millisecond. You have add this one and this one, then you obtain T3. But then you have to compute the T2, then you have to compute the T1. Do you think that this is easy? It is not easy, right? It is complicated. However, this is the final solution. So I think we can have 20 minutes break.